In this video we're going to be constructing a stem and leaf plot, and so going over the basics of how to do this again, but in this particular instance let's take a look at the situation. We'll talk about how it's different from a typical stem and leaf plot. It says an insurance company researcher conducted a survey on the number of car thefts in, say, a large city for a period of 30 days last summer. So we have our 30 data here. It says the raw data are shown below. Let's construct a stem and leaf plot, but specifically this is a little bit different than normal because when we construct stem and leaf plots, typically we only use leading digits. For instance, here I would say something in the 50s, something in the 60s, something in the 70s. But in this case, we want to use classes from 50 to 54 thefts, 55 to 59 thefts, 60 to 64, 65 to 69, 70 to 74, and 75 to 79. So essentially, instead of creating a stem and leaf plot, which we're going to do, as a matter of fact, we have our stem and we have our leaf. Okay. Instead of putting something on here for thefts in the 50s, 60s, and 70s, what we're going to do is we're going to modify this so that our classes can kind of spread out a little bit more. Since everybody typically looks like here lives in the 50s, 60s, and 70s, it might be more of a benefit to us to put two classes for the 50s, one for 50 up to 54, and then another class for 55 up to 59. And likewise with our 60s here, we could say 6 and 6, 7 and 7. Okay. So what we want to do is we want to first of all organize our data from smallest to largest, and so this would just take a second. We say starting with the 50s, it looks like we have in terms of our data we have 50 here, so we say 50. Are there any other 50s? No, but I do spot a 5 with a 1 after it, so we say 151, 2 51s. I don't see any other 51s, so we say 51, 51, 52, so I've got a 52 here. Any other 52s that we haven't crossed off yet here? It starts with a 5, ends in a 2. I don't see any other 52s, but I do spot a 53 here and a 53 here. So we got a 53, 53. Are there any other 53? So 53. And we say 54, anything with a 5 and then a 4 after it. Don't see any 54, but I do see a 55. So I've got at least one 55 here. Any other 55s? There's another 55. So we get 55. Any other 55s here? I don't see any, but there's a 56. We say, okay, so 56. Any other 56s? No. We got a 57 here and a 57 here. So you can see how as we cross this off, again, it just gets a little bit easier every time. We say, all right, so looking in the 50s here, not seeing many other data in the 50s. 57, here's a 58. 58. I'm going to put that down here, 58. 59. I don't see any other 58s, so I'm going to go on to 59. So we say 59. And then do I see any other data values that lie in the 50s? So no other 50s. We're going to hop up to the 60s now. Looks like 63. I'll keep my pen here. Do I see anything less than 63 that's in the 60s? Here's a 62. So we'll cross off this 62. So we say 62. I don't see any other 62, but I do see a 63. So we say 63. Any other 63 values? No. But do we see a 64? 6 with a 4? No 64s. I do see a 65 right here. So 165. 65. Okay. Another 65. So I say 65. Okay. Any other 65s? There's a 66. 66. Okay. Any other 66 values? Nope. 67. Okay, so we have 67. Cross that off. I don't see any other 67. 68. So we got a 68. I know at least I see 169 here. Here's another 69 there. So I'm going to put that down here. We say 69. I don't see anything else 11s in the 60s. So we're going to hop up to the 70s now. Looks like we have a 72 and a 73. We say 72, 73. And let's see here. No 74. Here's a 75. Looking up top, we have 77, 78, 79. Okay. So 77, 78, 79. Really quickly here, I just want to count up our data. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, okay? So I'm missing one here. What did I miss? And it seems that not being careful here, I missed a 75. So what I'll do is I'll put in a little caret right here. And I say, okay, I'm going to have to go plant that 75 back in here, but it's a good thing that I counted all of these up. As a matter of fact, I missed this on purpose, but I want you guys to see this. So the idea is that you should always go back and count your data, but now that we've got this in order, okay, let's take a look at how this would look in our stem and leaf plot. And just like we did in our last video here, we're just going to place in, we already have the leading digits in here. Let's place in the trailing digits. So we say, looks like in my first class I've got a 50, so we've got a 50. Let's put this in orange. 50, 51, a 51, so 51, 51, 52, and I've got a 53, and a 53. So here's my first column. I don't have a 54, but see, here's the thing. Since we're using classes from 50 up to 54, and then 55 to 59, this 55 right here and this other 55 actually are going to live right below these here. So I say 55, 55, 56, 57, 57, 58, 59, okay? So now we're into the 60s here. We say 62, 63. So we say 62, 63. No 64. 65 is going to be up in the next class. So I've got a 65, 65, 66, 66. So 66, 66, 67, 68, 69, another 69. So then we say 72. So 72, 73. So 73. 75 will not live in this class. As a matter of fact, it'll live in the next class. We say 70, let's see here, we got a 72, 73, 75, 77, another 75. We missed the 75 here, or I missed the 75. Don't let me include you on that one. 77, 78, and 79. Okay, so what conclusions could we draw? Well, we had a lot of car thefts in the 50s. I could see that right here. And then we could say, like, there was a pretty good amount in, say, the upper portion of the 60s. But for the most part, most of our car thefts somewhere in the 50s for any given day in a large city. But that's how you create a stem and leaf plot when you want to split up your classes into smaller subclasses. Cheers.